All right, let's get the show started. Hello, everyone. Thank you all for joining. Welcome to InRhythm Lightning Talks. I'm your host, Parag Katkar. I'm the head of consulting practices at InRhythm, and we have a lot of exciting lightning talks coming up that we have curated for you. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time. And each week, one of our practice area consultants shares their knowledge on the evolving technology trends in the industry that will keep you learning and growing in your career. As a part of InRhythm's Lightning Talk series, today our Android expert Satish Yadav is going to give us an overview of Kotlin Multi-Platform Mobile, which is also known as KMM. And Satish brings in more than 20 years of experience, and he is highly passionate about mobile development. With KMM, you can build cross-platform mobile applications and share common code between iOS as well as Android applications. And personally, I'm really curious to understand how and if enterprises can save time spent in writing and maintaining same code across different platforms. And can we retain the flexibility and benefits of native programming? So without further ado, let's get it started, Satish.
Sure. Thanks, Parag. Hi. Thanks, everyone, for joining this session. My name is Satish Yadav, and I am a senior Android engineer here at InRhythm. I'm going to talk about Kotlin multi-platform. We call it as KMM for mobile app development. So let's get started. So what is cross-platform in general? So it is basically creation of a software application that is compatible with multiple mobile operating systems. Basically writing the code once and deploying it on multiple mobile platforms or different platforms. Some of them support desktop as well as web. So there are different solutions available right now. I listed a few of them here. Flutter was started by Google a few years back, React Native by Facebook. Xamarin is now owned by Microsoft, Apache, Cordova, and KMM is basically started by JetBrains. As you all know, Kotlin language was introduced by JetBrains in 2011, and since then it is well adopted. In fact, it is the official language for Android development nowadays. So it's pretty cool language. So I'm going to start with Kotlin KMM. So KMM purely uses Kotlin as a language and shared across different platforms. So what are the prerequisites required for KMM development? These are the tools or softwares you need to install. Basically, Java runtime you can download from Oracle website, Android Studio or IntelliJ. I prefer Android Studio because I'm very used to it and it has very rich plugins you can use, and install a KMM plugin inside it. Xcode you can download from the App Store on your Mac. CocoaPods is optional, but you can download and install it through command line. KDoctor is again optional. It's a tool from JetBrains. Basically, it is a diagnostic tool where you can run and see if the environment is set up right for your KMM development. So let's get started. I'm starting with the live demo here. So I have installed all of the softwares, but let's install a few of them, few tools which will let us know that we are all set up or not. So start with installing the KDoctor. So if you don't have Brew, basically go to brew.sh and run this command over here, and it will install Brew on your Mac. I'm running this command right now. So either it will install, because I already have installed it, it will either install or update my KDoctor. And when I run KDoctor, it will basically list down all the required softwares I need for KMM. So if you see, it will put a check mark against each of them. Have everything installed properly. There is some issue with CocoaPods, I guess. Since it's optional, we don't have to care about it. But basically, you need to have Java, Android Studio, and Xcode for this development. So starting with Android Studio, First, once you open Android Studio, install the KMM plugin. You can do that by going to Android Studio, click on settings. Some of you guys might have it as preferences. It's basically changes based on what OS you are running on Mac. So for me, it is settings. So go to settings, go to plugins, and then in the marketplace, you can basically search for Kotlin Multi-Platform. So here it is. So I have already installed it. So click on OK. Once it installs, you have to start the IDE, like restart the Android Studio. Once you have this plugin installed, and when you start a new project, so let's start a new project. So Android provides you this wizard, start a new project, what type of project you want to build upon. So now you will see that I have two more options here, like Kotlin Multi-Platform App and Kotlin Multi-Platform Library. I start with the Kotlin Multi-Platform App. Give a name to my application, let's say demo. With whatever package name you want. It says minimum SDK for Android 24. And that's fine because it covers almost 94% of the devices. So you're good with that. These are these modules which will be included in my project, Android app, iOS app, and a shared module. So I can change this name, but I like to keep it as default. And with the iOS framework, this is important. You can choose from CocoaPod or regular framework. CocoaPod is the dependency manager for iOS. But to keep it simple, just use regular framework for now and click on finish. So it will basically create an hello world kind of app for you. I already created that because just to save time on building the project. So this is my hello world kind of app over here. So if you see the project structure, right, it has an Android app, iOS app, and a shared module. So Android app is like any other Android app, which I can run a standalone Android app. iOS, same thing with the iOS app. And shared module is where basically all my business logic resides, which is common between both the apps. So I don't have to write it twice. And within share module also, you'll see there is a sub-module, Android main, common main, and iOS main. So let's try to run this app right now. I'm running it on Android device. First. Yeah, so it just says hello and the name of the OS, which is running on my emulator. And then I go ahead and run the iOS app. And the cool thing about this is I can run my iOS app right from the Android Studio with this plugin. So on the right, it's the Android emulator, and on the left is the iOS simulator. There you go. So just displaying a message, hello world, right? Hello, basically, and a message name. So if you look inside the app in my common module, I have this class called greeting, which is basically saying hello and the name of the platform. So the name of the platform is coming from my platform class over here. It has an interface which returns a string, a name, and a platform. So if you see here, I'm calling this method get platform. It's just a function name. But what's interesting is you'll see that there's a keyword called expect over here. So what does that mean? So it's very specific to KMM, this keyword. When I say expect a function name, that means I had to implement a corresponding function in my native code or the submodules over here in Android main as well as iOS main. And why do we do that? So let's say if I go to platform, I have a function name get platform, but it has a keyword called actual. So basically, expect and actual are KM keywords. So when I say I expect a function or a class, I have to implement a I have a corresponding implementation in my native or the native submodule. That is because it is returning a string which is coming from a Android SDK, which the common module doesn't understand. So common module is supposed to have only my business logic, nothing related to individual platform, right? Like making an API call or doing any calculations or business logic will go in common module. But my Android main as well as iOS main will only have the logic which relates to the platform. So it keeps them separate and they are independent. So if you see here, I'm getting the name of the version, iOS version over here from the iOS module. And if you look at my Android app, which Android and iOS app, if you look in the Android app, I'm basically implementing the UI to display that that message. So if you look at my main activity and calling this greeting view, and greeting is coming from my common module, greeting class, and I'm just displaying that text over here. So whatever is coming back from over there. And same thing for iOS. So if I open this iOS, which I think I already have open here. Yeah. So this is my iOS project, which is implementing that UI. So it is getting, if you see here, I am importing the shared module here. And my greeting class is returning the greet method, and which is returning me that text. So it's important to have only the common logic inside in my common module. Whereas anything dependent, which is dependent on iOS or Android, I put it in my submodules, Android main as well as iOS main. So for example, let's take another example. If I want to show a date over here, right? What I will do is the common module only understands Kotlin. It doesn't understand Java or any SDK related APIs. So let's write one common method here. So I say expect. Let's call it get date. And basically it just returns me a string, a representation of the date, right? So I'm just declared this function here. So if you see, it is complaining me that get date doesn't have actual implementation. So what I have to do is I have to go in my native submodule, and I write an actual function for that. Get date, which returns me a string, which is just a date function, let's say. I'm using a java.util.date here, and just returning a string for that. So if you see here, I can import the Java classes over here, which is very common for Android project. We use a lot of some of the Java classes. But if I try to import the same in my common module, so if I say import Java, it cannot find it because it doesn't understand anything but Kotlin. So I can't do this in my common module. And same thing with iOS. Anything specific to iOS platform, I have to put it over here. So let's say it's still complaining me that I still don't have an iOS implementation for this actual implementation for this function. So I have to go in platform and write an actual method for that. So it returns me a string equal to, let's use ns date. String. So anything you want to import from iOS platform, the way it works is you have to say import platform dot, and whatever classes related to iOS you can import. You can just say dot, and it has access to all the APIs from the iOS SDK. So let's run this and see what it says now. And if you see now, the compiler is gone from my common module because I implemented those methods. So you'll say, like, why do we have this expect and actual? I can just have my interface, right? Interface over here. And one thing I forgot to return, instead of returning hello platform name, I can say today is, I have to write private val. A little bit date. It should be a string. Get date. And then I just simply return this date. Yeah, so back to that question, that why do we have get an expect an actual instead of, I can just say it's displaying the date now. So same thing on iOS, it will display a date for me. I can just have my interface and implement them in my native submodules, but get with the expect and actual, I get more power, more options. Like I can inject any different classes which I want in each of the platform. Like for iOS, I can inject something else, some other class, and for Android, I can inject something else. So it's very important because when you are integrating like third-party SDKs which are not supported on the cross platform, I can inject them over here in this platform over here. So this is a simple example, but I created a sample app basically. Look at some other app. So what I'm doing is here is I'm using the InRhythm block which we have here. So I captured all this data and put it in a JSON feed, which I have it over here hosted on a mock API server. So it's basically returning me a JSON feed of the blog articles, and the way I implemented, I'm using a basic MVVM model. So if you see in my common main module, I have this API which is calling the APIs. And one more thing I forgot to explain, that in my common main, I also cannot use any libraries which are written in Java or other language. For example, on Android, we use a common networking library, Retrofit, which is written in Java. So I cannot use that here. But they have there are some libraries which are purely written in Kotlin. For example, this Ktor library, which I am using for networking. So it has a class called HTTP client, which I'm using to fetch that data. So the article API will return me that API data, and then I have a repo, return repository, which returns that big data to my view model. And my model is like this for the article over here. It has all those fields which I'm using in my JSON feed. And on Android side, I haven't implemented this on iOS, but on Android, I'm just using a Jetpack Compose to display that data. So let's run that. So this is how it looks. All my blocks are listed over here. So I can make it look very similar on iOS, but the logic of fetching the data and the data layer is in my common module, so I don't have to write it twice. So let's say I can also make it look different on both the platforms because my UI is still native. I am writing a UI natively. So let's make some changes here to make it look different. So instead of row, I'll say column here. This is again Jetpack Compose stuff. So center vertically should be vertical alignment for my column. When I get rid of my width and height both, so it will max width. This should be center horizontally because I'm using a column. And let's see how it looks now. Yeah, so same data, but I made it look different than the previous view. So I'm having the same data, but I can make it look different on iOS and Android. So that's the power of KMM APIs. One more thing, if you want to cache the data locally, we usually use a Room database on Android, and I believe core data on iOS. But I cannot use Room database because it's an Android library, a Jetpack library in my common module. What I can do though, I can use SQLite database, which is common between iOS and Android, and I can write all my code to access the data or creation of database, insert SQL queries inside my common module. The only thing will differ is the SQLite driver, which is different for each platform. So I'll implement those drivers in my submodules. Like for Android, I'll have my driver, SQLite driver over here, implemented here using, of course, expect and actual, and in iOS over here. So that's still possible. So I guess that's it for the demo. And the way it works is whenever I build an Android app, like when I run the Android app, it includes basically my Android app and things from the common shared module is Android main and common main. And similarly, if I build iOS app, when I run an iOS app, it is going to include my iOS app, iOS main, and common main. So common main, if you see, common main is common between both the builds, where my business logic is there. So going back to my slide again. I listed some of the important libraries we can use with the shared module. They are purely written in Kotlin. For networking, I'm using Ketor. For dependency injection, there are multiple options. I can use Coin, Coding, or Kotlin Inject. For GraphQL, there's this library called Apollo GraphQL client. And this was basically specifically written with KMM in mind. So it fully supports KMM. I can use that. I listed some important links over here. Onboarding is for basically getting you started on KMM. KMM samples, there are some sample apps on this, which you can refer to. And if you look at these sample apps, the features column is important because it's basically each of this app is focusing on these features for KMM, like how are we using expect and actual keywords in our platform. So this app talks about that. Redux is again state management way of managing the state. So this KMM, the RSS reader app, will talk about that. We have video tutorial. Then this app will have an MVI architecture inside it. The common question is, can I have my view model inside a common common code. So yes, it is possible. So this app is explaining about that. I can have my shared view model inside the app. Yeah, and then there is this YouTube channel from JetBrains. It has a lot of webinars talking about KMM, and they have actually interviewed the people from different companies who are actually using KMM and their experiences with it. So you can refer to that as well. This is a brief survey done by JetBrains. Basically, you have an option how much of you can use in the shared code. Like for networking, 85% of your code can go into a shared module, data storage around 70%, analytics, logging, algorithm computations, your state management, your presentation controller, view models can also be in the shared module. So a lot of things you can share. So what are the advantages of using KMM? It's basically saving you time and effort by having a shared code logic, having a great performance because it's still a native UI you are implementing for Android and iOS. You have flexibility to choose between what is shared and what is not, smooth integration with existing project. I can modify my existing project and start using KMM, native performance because of the native UI, and you have easy access to device capabilities without any overhead. Like if you want to access camera or GPS, you can easily do through the submodules. So in my past project, I actually worked on the takeaway from this, like why I feel KMM is better than other platforms or solutions, because in my past project, I worked on Flutter. We are migrating the apps into Flutter, and everything is good with Flutter as well. Like you can have a good native performance as well. But we hit a bottleneck when it came to integrating the third-party SDKs, because most of them were not supporting Flutter, like for example, for analytics or for crash reporting or for A/B testing. We were using native SDKs before, and we could not have the Flutter equivalent for them. So we end up writing our own plugins. Like it is kind of a bridge code, which is talking to native layer again and fetching that. But with KMM, I think because of those submodules and with expect and actual implementation, we can easily integrate into that. So before I ask questions, so there are some basic questions people ask about KMM. Like one question is like, can I create an iOS app on Windows using KMM? So answer is no, unfortunately, because iOS mostly works on Mac. But thing is, you can basically have your Android app and the shared module on developed on a Windows machine, and you can still share the code through Cocoa Pods or through some shared repository. Another question is like, can I put my view model and presenters in shared module? Of course, yes, I said it adds a little bit of complexity. Like you have to manage a state carefully when you put it in the shared module. But yeah, you can still share them. Like I showed that link for the example project. Right? There is an example for that, how you can put your view models in the shared project. And now I'm open for questions.
Hey, Satish, first of all, thank you so much. Excellent talk. Really loved how you did the live demo and covered everything. I have a question for you. I'm really interested in knowing your thoughts on how you see KMM affecting the workflow between different development teams. Because right now there is a certain workflow and the interaction that they follow. Like, do you see KMM coming in, getting more popular, changing that?
Yeah, I mean, KMM, they have got their beta version last year in October, I believe, and since then it's just they are improving on top of that. So with workflow, what do you mean? Like how do you work between different teams?
Yeah, different teams, like the team that is building UI or teams that are building APIs. Like currently,
Yeah, of course. Yeah, like I said, the UI is still native, right? So we still need Android and iOS developers. iOS developers are writing their own UI in Swift UI and Android in Compose. So they can definitely work like separately and write the UI, and while the share module can be written by both the developers, right? It's still shared module. It's in Kotlin, but Kotlin is very similar to Swift. I believe, syntactically. So yeah, both teams can be involved.
And is it going to affect, like, there is always a complaint or like parity between iOS and Android falling behind? You see this helping in that?
Of course, this will help because your business logic is ready to be utilized by both the teams, right, at the same time.
Yep.
And writing UI won't be that complex once you have your main core logic written.
Nice. Thanks, Satish.
I was going to ask a question, but I see Michael's hands up, so I'll let you go first.
You had a screen where you're showing the list of advantages. Right off the top of your head, what would be the major disadvantage to doing this?
The only as an Android developer, I feel very comfortable. It's in Kotlin. iOS developers might feel little isolated because, but they still get to write the Swift UI, right? So it's not bad as other platforms. They still get to because I have seen in my previous project that once we started migrating to Flutter, one of the iOS dev and one of the Android dev left the company because they wanted to stick with the native platform. But with KMM, I think we have opportunity that you get to work on everything. Right? You get to work on Kotlin, you get to work on Swift, you get to work on native Android APIs as well. So it keeps everyone happy, basically.
So following up with that, like how easy it is, do you think, for like an Android developer to come in and be able to, work with KMM?
It's very easy. I'm an Android dev, and it was very easy to me write that interface, which the same sample app I showed to you just now. It's very similar what I write on Android. So, and because it was Kotlin, it was pretty easy for me to write that module. And MVVM design pattern or MVP or any other design patterns are very similar on both the platforms. And we can use KMM to mimic that very easily. So it wasn't hard at all.
Okay. What about testing? Right. What's the ease versus the difficulty of being able to test the logic that you're writing in KMM?
So because we have kind of like three modules here, right? Three modules, shared module, iOS and Android app. So the individual unit test cases will reside in each module. For shared module, I believe it's the same thing. What the JUnit use cases, unit tests we write using JUnit. So they have the libraries for that for testing as well. I guess let me go back to Android Studio again. And if you go and see here we are using Gradle for dependency management. So if you see here, Android, these are the models which are using. So it's pretty similar for Android as well. You can still use JUnit for testing.
Okay. Yeah. Awesome. Thanks.
One quick comment I would have is the question, actually more than comment, is like the whole Apple ecosystem. There is an inherent advantage, I've been told, to be part of the Apple ecosystem, given the pace of innovation that happens or the pace of changes that Apple brings on. So is there like a built-in lag when Apple releases something to keep up with it? Like this whole KMM platform will have to, like, it'll be like a 1 quarter or 2 quarter or 3 quarter lag that comes with that.
Lag in what space? Like I said,
to keep up with the changes that Apple is doing. Like Apple may change the whole, they keep on tweaking stuff every now and then, right? So
tweaking, you mean the software tweaking?
Yeah, their whole core systems, right?
Yeah, that's applicable for Android too. But like I said, we're using mostly KMM for shared logic, right? Shared business logic, which is not going to be affected by those changes. I believe whatever SDK modifications are happening or are happening on the UI side, which can be easily adopted because we are not changing that with this. We are still writing the native code in UI in the native code. So that's what not going to change. We are still going to adopt those changes easily.
Okay. Good, really good talk. Thank you, man.
Yeah. And one of the questions I think Greg had asked me, can I integrate KMM in my existing iOS project? So if I was doing it for an Android project, answer to that is like I would create a KMM library first as a library project, and then to add that as a dependency in my Android project. So I believe same thing can be done for iOS project using CocoaPods. So it's still possible to answer that.
So I'm really excited to announce that over next 4 weeks, we will be hosting InRhythm's quarterly summit, which includes a series of 6 hands-on interactive coding workshops on the latest technology trends. What we have right now here, it's a quick lightning talk. Even though Satish made it really in depth, usually these are like quick lightning talks, which we do it every Thursday evening. But what's coming up is our quarterly summit. And I know there are a lot of mobile engineers and leaders over here. So quickly, we're going to have an in-depth workshop on KMM on 7th of April. Also, we are having a in-depth workshop on Swift async await. That's on 28th of March, where we have DevOps, web, SDET. In fact, we are kicking the workshops tomorrow with Microsoft Playwright, where you learn Playwright's features and write a series of comprehensive tests against a test application. It's getting really popular as an end-to-end testing frameworks. And we're going to learn some of the advanced feature, the powerful debuggers, and enhanced reporting. And yeah, I'm really excited. So please join us tomorrow at noon Eastern Standard Time in our journey of continuous learning and growth. Thank you all once again for joining. All of you have a wonderful evening, and I'll see you guys tomorrow in our quarterly summit.